YouTube channel Mathematics with Usman. I'm back today with another tutorial, and this time it is about the projectile motion, which is the topic from CAIE syllabus. This is the first tutorial in my series on projectile. Consider the footballer standing over here. He chips the ball in the air. The ball went to its highest height over here and then drops at this point. This particular type of motion is called the projectile motion. And the path followed by the football while it moves from this initial point to this dropping point over here is called the trajectory of the football or the trajectory of the projectile. When we throw the ball in the air or the footballer kicks the ball in the air, there is some initial velocity given to the ball. It's represented with u, which is making an angle theta with the horizontal. Students, as the football moves in the curved path, so its velocity will be tangent to its curve. There are three further things that we have to discuss. The time taken by the football while reaching from this point to this point over here. It's called the time of the flight. The maximum height attained by the football, which is this vertical height, it is called the height of the projectile. And the horizontal distance from its starting point till the end point is called the range, or we can say the distance that the football travels in horizontal direction. Students, before discussing this projectile motion, there are certain prerequisites of the projectile motion that you need to understand. Number one, it is called the soviet equations. We are very much familiar with it. If you are not, we have to learn this. There are 5 basic equations. Number one, v is equals to u plus a into t. V is the final velocity, where this u is the initial velocity, a is the acceleration, and t is the time. Second equation says as distance is equals to u times t plus half a times t square. The third equation says 2as is equals to v square minus u square. The fourth is s is equals to v average into time, and the fifth one is replace this average with initial velocity plus the final velocity over 2 multiply t, and this is equals to s. These are the 5 soviet equations that we need to understand. We need to memorize them by heart. Then student, if we want to understand the mathematics of this projectile motion, we need to make few assumptions. Here are few of the assumptions. When the football is kicked in the air, this football will be considered as a particle. Whatever the thing, whether it's the skyrocket that is projected in the air, must be considered the particle. Or the golfer who hits the ball in the air, that golf ball should be considered as the particle. But in our case, as we are considering the football, so we will consider it a particle. The second thing is there is no friction in the form of the air resistance or the cross winds that are blowing. So there is no cross winds blowing. For example, for instance, we will consider we are taking this experiment on the moon or any other planet where there is no air. The third assumption that we have to make is the acceleration due to gravity is involved. Since we are considering the vertical plane, so we have the ball or the particle moving in the vertical direction, and the gravity is acting downward, whose value we are going to be taken 9.8 meter per second. Another very important thing, students, that you need to master before going into the projectile is the resolving of the forces or the resolution of the vectors. Just consider when the football or the particle, in our case of the projectile, is thrown in the air, it is having its two components. If I drop the perpendicular from this point over here, we are having the right angle triangle over here. See students, this side theta, the opposite side to S is perpendicular. Here we are having the 90 degrees angle, so this side should be the hypotenuse and this side is the adjacent side, or what we call it, the base. Students, there are two components of this U. One is along the vertical axis and we call it the vertical component, that one of the rectangular component of U, and the other is along the x-axis or the horizontal axis and we call it Ux, which is the horizontal component or the x component of the initial velocity U. Now students, as you are well aware of these two statements, whether you use, some people have curly brown hair through proper brushing or SOHCAHTOA, you have to write this in the form of trigonometric ratios. And we know that the first trigonometric ratio, which is called the cos of theta. So according to these two, that will be equals to the adjacent side and the hypotenuse, that is Ux over U. Now if we arrange them to find the horizontal component, that will be equals to U times the cos of theta, that is the angle with the horizontal. Now if we consider the sine theta, that will be equals to, some people have, so perpendicular over hypotenuse, and perpendicular in our case is the y component of U and divided by the hypotenuse, that is U. Now if we need to find the vertical component, that will be equals to U times sine of theta. So students, to better understand the mathematics of the projectile, let us consider the typical example. A particle P is projected at an angle of elevation of 50 degrees at an initial speed of 25 meters per second. The particle in our case is going to be a football. So let's say a footballer who chips the ball in the air goes like this. If we draw this in a plane, horizontal and a vertical plane, then we are going to have the starting point at, which is the origin over here. Now when the footballer kicks it in the air, it is giving it some initial speed given to us, and in this case it is over here equals to 25 meters and is tangent to the curve. Students, as football is moving in two directions, horizontal and vertical, and we will consider motion of this football or the particle in horizontal as well as the vertical direction. So we have to resolve this U equals to 25 meters per second into its components. So draw the perpendicular over here. This component is the horizontal component 25 cos theta, cos of 50 degrees, and this is going to be the vertical component 25 sine of 50. Students, we will consider both the movements separately. In the horizontal direction, remember, there is no air resistance, we have agreed to that, so there is no acceleration produced, and the body will move with the uniform speed of 25 cos of 50 on the whole path as the projection on this path when the particle is moving along this path. And while in the vertical case, the particle is moving vertically over here, but since G is involved over here, so it is going to be accelerated. It is moving up, it is decelerating. When it is coming down, it is going to be accelerated. The three things that you may be asked to find, number one is this maximum height over here that the projectile can attain. It is represented with the capital H. The second thing that you may be asked to find is the range, means the horizontal distance that a football will travel along. Number three, what is the time taken by the particle while it moves from its starting point to the end point over here. It is called the time of the flight, and let's call it time t. Now first thing that we need to find over here is the time of the flight that the football takes while traveling from this point to this point over here. Now to find the time of the flight, let us consider the vertical motion, and it is going to be positive while moving upward direction. So students, when particle is moving in the vertical direction, it will start over here, it will move its maximum point and then falls over here. Now consider the vertical motion. At this point, its vertical distance was 0. And when it comes back over here, see the vertical distance. S is again 0. So in the vertical direction, the displacement was started from 0 and ended at 0. So there is no vertical distance traveled. Hence, the displacement is going to be 0. The second thing is, what is the initial speed? And since it is moving in the vertical direction, so we have to consider the vertical component of the initial speed. That is going to be u equals to 25 sine of 50 meter per second. While it is returning, its final speed or the final velocity is going to be the same, but in the opposite direction. So its final velocity is minus 25 sine of 50. Another important thing is the acceleration. Since it is moving in the vertical direction, and we have to consider it equals to the gravity, which is equals to minus 9.8 meter per second. And the thing that we need to calculate is the time, which is represented with capital T. Now students, you have to consider the SOVAT equations. Which one is suitable to find the time? And the easiest of all is going to be V equals to U plus AT. Now see, we are given with all the values over here. We are given with the value of V, we are given with the value of U, and we have the value of A as well. Only T is unknown here. So let us substitute the values. V minus 25 sine of 50 equals to U 25 sine of 50, and A is equals to minus 9.8 and to T times. Now if we calculate T, it is going to be 3.91 seconds. Now the second thing that we are interested to find out is going to be the maximum height attained by the particle P. For that particular case students, once again we are going to consider the vertical motion of the particle. And for the vertical motion, the maximum height in our case is going to be equals to h. So the displacement s is equals to h. The initial velocity in the vertical direction is the vertical component of the particle, and that is going to be 25 sine of 40. So u is going to be 25 sine of 50. Students, important thing to realize over here is when the particle reaches its maximum height over here, its final velocity becomes 0, because for the fraction of the second, particle is going to turn. It will change its direction. So at that particular moment, V is going to be 0. And it is moving with the acceleration of g equals to minus 9.8 meter per second, as it is moving in the opposite direction of the gravity. So we have to consider the negative sign, and the time information is unknown. Now students, we have to decide which SOVAT equation is going to help us to find out the unknown h in which we are interested in. And the best equation of the SOVAT is going to be 2as equals to v square minus u square. Now we have all the values except the value of s, which is equal to h. Now substituting all the values, we get this equation, and now we have come up with the solution of h, that is going to be 18.7 meters. Finally, the last part of the question, that is to find the horizontal distance called the range r. Students, for this particular case, we have to consider the horizontal motion of the particle. And for the horizontal motion, there is no acceleration, since there is no air resistance, there are no opposite forces. So body is moving with the uniform speed. So we can easily find out the distance, that is going to be s equals to u times t. Now students, for the horizontal motion, we have to consider the horizontal component of the initial velocity, that is going to be 25 cos of theta, and time is the time that the body has taken from its initial point till the end point, and that is the time of the flight. So the time is going to be 3.91. So let's substitute the values. S is going to be r, u is going to be 25 sine of 50, and time t is going to be this t, which is 3.91. So substituting the values, we are going to get r equals to 74.88 meters. And this brings us to the end of today's tutorial. I hope it has some value to your mathematical concepts. As always, thank you very much for watching Mathematics with Usman. See you in another tutorial with another topic. Till then, it's goodbye.